Hi everyone, my name is Neeraj Reddy Parige. Today I'm going to present my fog and edge project titled Energy Efficient Dynamic Task Offloading for Secure IoT Edge Cloud Computing. My project is based on a journal paper titled EEDTO Algorithm for Blockchain Enabled IoT Edge Cloud Orchestrated Computing. So before let's see what are IoT devices. IoT devices are like sensors, smart cameras and wearable devices which continuously generate large amount of data, and these tasks are either processed locally on the device or offloaded to centralized cloud servers. IoT devices are resource constrained, meaning it has a limited battery, low processing power, and minimal memory. On the other hand, offloading everything to the cloud servers or edge servers introduces latency and network congestion. Also, data privacy became a major concern as sensitive information travels over the network. Many existing models fail to handle the trade off between energy efficiency, latency, and security simultaneously. Our goal is to replicate and understand how dynamic offloading decisions can be used to handle these trades off. So, this is the proposed architecture diagram. It is a three-tier system which has IoT layer, edge layer, and cloud layer. IoT layer generates tasks or the tasks are either processed locally or offloaded them, and offloading decisions is taken care by EEDTO algorithm. It decides where the task needs to be processed either in cloud layer or edge layer. Edge layer is the layer or servers which are situated near to the IoT device, which has significant which helps in reducing data transmission latency and limited power, whereas cloud layer is used for handling intensive computations and large data sets. Blockchain layer is also integrated across cloud layer and edge layer to ensure secure and verifiable task offloading. Each transaction is logged for immutability and traceability for security of the data. Now, the EEDTO algorithm. It is the core of our simulation as each task is rigorously evaluated based on three critical objectives, which is energy efficiency, latency, and security. This algorithm computes a weighted score and of each potential offloading destinations. So this score is calculated based on the formula alpha into energy score plus beta into latency score in gamma into security score, where alpha, beta, gamma are the user defined weights. Suppose, for instance, a task needs to be computed in an energy efficient way. Then the energy efficient weight, which will be, which if we give 0.8, then it favors devices with superior energy performance. And then the algorithm selects that layer and with the highest score and cloud layer. If the cloud layer is chosen, then the algorithm further decides which server needs to be utilized. Next is a simulation workflow. Here we can see the entire workflow of the simulation. First, the server initialization is done. Next, tasks are generated using random characteristics. Third is the scores are calculated using EDT algorithm. Fourth, the offload decision is taken by scores calculator. Fifth is the blockchain logging for the every transaction, offload transaction. Execution and validation of the tags on the each layer is done, and the metrics are calculated for the detailed analysis. Here, I will walk you through the entire workflow of simulation. First, we will take an example. We'll pass all the parameters based on the different configuration and run simulation is triggered here in the simulation.java, and it takes all the parameters and the blockchain service is created. EDTO algorithm is created and devices are initialized based on the number of devices which we give using IoT device.java and for the edge server.java and the cloud server.java. And in the run here where the generate task and process task is done. First, in the generation of task we are creating a bunch of tasks of three categories like lightweight, medium, and intensive using the probabilities. Like we give 60 30 is to 10, so tasks are created in the similar fashion of a 60 30 10 ratio, and the processing of the task is started here. It picks the task from the array list, and EDT algorithm offloading decision here is taken care from the EDT algorithm.java. And after here, the target device is chosen. And if it is a IoT device, the task is executed locally, or else or else it will chooses the target device, and whether it is edge server or cloud server, it chooses, and the execution of the task is done. And here the statistics of all the statistics and results are collected. Here in the output, here we cannot see in nothing, but once we run the simulation, we can see all the graphs and reports here. Ye- Here, after the simulation is run, simulation summary report is generated for all the four configurations. We can see the number of tasks generated, number of tasks offloaded to the edge, cloud, and average energy it used, and number of blocks created. And these are all the different plots based on the parameters. Here, for you can see the cost comparison chart. Here for the baseline energy focus, latency focus, and security focus. Similarly, for the offloading comparison and the response time comparison of all the four configurations as shown here. Here we can see all the, as we have run all the simulation for the four configurations using different weights. I have plotted a simple bar graph for the energy consumption. Energy focused configuration achieved lower power consumption as expected, and for the latency, we can see for the latency focused has a significantly reduced task completion time, and for the security focused configuration showed least security overhead. Conclusion and future direction. To conclude, we have successfully implemented and evaluated a secure, adaptable offloading simulation using EED2 algorithm, and we analyzed how the goal affects system performance. In future, we can also incorporate real-time mobility models for moving IoT devices, and support dynamic network fluctuations and failures, and extend support for the multi-hop offloading. Thank you.